3 sampling sites in the North River in Bridgewater, Virginia, and 3 in the South River in Waynesboro, Virginia, were used due to known snail populations in these rivers. Each sample site was separated from another by 20 to 50 meters and marked off at each location using a half-meter squared marker. At each sample site, pH of the river was measured using a pH probe. Next, percent algae coverage was measured using a grid method. Rocks with a diameter larger than or equal to 9 centimeters were included. The total area covered with algae on each rock was divided by the total area of all rocks in the plot. Next, all snails were collected by hand at a water depth of 0.1 to 0.5 meters. Separate containers filled with river water were used for each plot to ensure survival of the snails as well as to keep the organisms separated. Collected snails were then taken back to the laboratory for taxonomic identification.
The largest abundance of snails in the North River was consistently Limnaeidae, with 34 collected in Plot 1, 29 collected in Plot 2, and 13 collected in Plot 3. Planorbaridae was the least abundant family, with only 2 collected in Plot 1 and 0 collected in Plot 2 and 3. In the South River, the largest abundance of snails was also consistently Limnaeidae, with 20 collected in Plot 1, 16 collected in Plot 2, and 3 collected in Plot 3. Planorbaridae was also the least abundant family, with 0 collected in Plots 1 and 3 and 1 collected in Plot 2.
Plot 1 of the South River reported the highest percent algae coverage with 98%, while Plot 3 in the North River reported the lowest with only 10%. 83% algae coverage was found in Plot 1, and 68% algae coverage was reported in Plot 2 of the North River. Plot 2 of the South River had 83%, and Plot 3 had 60% algae coverage.
A higher density of snails was found in the North River than in the South River, even when the percent algae coverage was similar. It can be seen in the figure that a higher percent algae coverage is associated with a higher average snail density per half meter squared. Analysis of results showed a slight positive correlation between the density of freshwater snails and percent algae coverage, supporting our hypothesis. Limnaeidae had the highest density in both rivers, constituting for 83.5% of the total snails found in the North River and 86.6% of the snails in the South River. A possible explanation for the extremely high density of Limnaeidae in both rivers is that Limnaeidae are algivores, while Planorbaridae are detritivores. Therefore, this family of algivores would require habitats with high percent algae coverages.
There may have been a correlation between pH levels and snail density. However, due to equipment malfunctions, pH readings could not be included. These findings are significant because they could lead to a possible explanation for instances in which low snail density is paired with high percent algae coverage. As global temperatures have consistently been on the rise, optimal algae growth temperatures have been at risk for change. This deviation in temperature could lead to a decrease in amounts of preferred algae available to freshwater snails. Altered temperatures may have an adverse effect on snails whose diets primarily consist of particular types of algae. As high percent algae coverage may still be found, a lack of preferred algae may result in a decreased density of snails.